All right, folks. So today's lesson is all about section 5.3, which are more functions on trigonometry. And we did work on sine, cosine, and tangent last time. And in this section, we're going to be working on secant, cosecant, tangent, and cotangent of 60 degrees, 45 degrees, and 30 degrees. We will also use reference angles to evaluate the trigonometric functions of secant, cosecant, tangent, and cotangent. We will use the even and odd trig functions, and we will recognize and use fundamental identities in some questions. And overall, we will be evaluating the trig functions with the calculator as well. So with that said, your assignments are open in the Canvas. So this week, your goal is to finish chapter 5. So 5.3, 5.4 are open. The review of the quiz is open and the quiz is open as well. So today is Tuesday. I will be walking you down through 5.3, 5.4, and then I will walk you down through the review probably in the next meeting, and we'll open also chapter 6 for you guys. Now, scrolling down through the page and making you familiar with a couple terms which we did last time. So last time we were talking about the angles, the basic angles, and here's another picture of the angle. We were talking about the unit circle. So this is indicating a point on the unit circle XY with a radius of 1 and an angle of T, as you see in the diagram. So now sine, cosine, and tangent you were familiar with. These are the basic formulas if you make a triangle from the given point with the unit circle. So tangent is y over x, secant is 1 over x, cosecant is 1 over y, and cotangent is x over y. To explain that thoroughly, I am gonna draw this triangle that I showed you with the x point from the unit circle, that it goes this way, and this is how the triangle was made. So if I drop a line right here, let's say right here, and then this angle was marked as the angle T. So from T, this side is hypotenuse. This side is adjacent. And this side is opposite. So I'm about to write here the SOHCAHTOA rules. Hey, Jonathan, I see you joining in. I have started the lesson on section 5.3, and I was making sure that I recorded just in case,
Okay. I I almost didn't join today because the link wasn't attached in the announcements.
Is it? I attached it. Maybe somehow it got missed.
Yeah.
So I can double check on that.
Okay.
Let me see what is going on in there. So right here, announcements. And whenever it happens and you guys couldn't find the link or it's not attached, what you can do is, as you see on my page, there is Tech Connect Zoom, this one.
Oh, yeah, yeah.
Yeah, that's where the link is always present.
Okay, yeah,
So
that's
I
what I
am,
used to join. Yeah.
okay, that's where you found it?
Yeah, yeah, yeah.
Yeah, so might be that when I copy and paste it, that didn't paste the link over there. So I'm gonna do it right here. Okay, so I paste the link. I hope it goes to the people. Thank you for letting me know that difficulty, Jonathan. And I see Matthew is replying. Um,
Yeah, no problem.
yep. Okay, so I hope Matthew gets the message as well in time. So I was right here talking about the trig ratios. If you remember, we did trig ratios last time, SOHCAHTOA. So this is a extension to that lesson, SOHCAHTOA, and we were using the unit circle. So today we're going to be working on secant, cosecant, and cotangent along with rest of them. And I was drawing this triangle indicating that if there is a point XY on your unit circle, and here's a triangle with angle T, then this side, horizontal side, which is adjacent side to angle T, is the X side. And this side, which is the opposite side, that's the Y side. And hypotenuse is 1 because this angle is taken from the unit circle. Like if you're walking on the unit circle, there is a point and you make a triangle. So then if that's that, from the SOHCAHTOA rules, I'm going to write the words here on the side. SOHCAHTOA. So sine, S stands for sine, O for opposite, H for hypotenuse, C stands for cos, A for adjacent, H for hypotenuse, T stands for tangent, O for opposite, A for adjacent. So for tangent T, opposite over adjacent means Y over X. And now extending on these, the secant is opposite of the cos. So from cos, if you flip it over, that becomes secant. And cosecant is opposite of the sine. So like sine is opposite over hypotenuse, cosecant will be hypotenuse over the opposite. So hypotenuse here is 1 and opposite here is y. So that's why the cosecant formula is 1 over y. Secant is reverse of the cos. From SOHCAHTOA rules, cos is adjacent over hypotenuse. So secant will be hypotenuse over adjacent. Hypotenuse is 1, adjacent is x. The cotangent is opposite of the tangent. So the tangent formula is opposite over adjacent. Cotangent will be adjacent over the opposite. So adjacent here is x and opposite here is y. So x over y is the formula for your cotangent T. And I welcome in Isaiah, Matthew, Valerie, Vladimir, and I'm glad that you guys were able to make it, and all the credit goes to Jonathan that he was able to come in and tell me that, okay, the link is not showing up in the announcement. So then I resent it over there. Somehow it didn't get printed over on your side. Okay, with that said, today's lesson is all about the trig ratios. So all that is written on my screen is so far is your SOHCAHTOA rule. And I'm pointing with the arrows that cosecant, the secant, and the cotangent. The cosecant is opposite of the sine, secant is opposite of the cos, and cotangent is opposite of the tangent. And this triangle is taken from a point on the unit circle. If there is a point xy on the unit circle, this side will be x, this side will be y, this will be 1 because it's a unit circle. And then applying SOHCAHTOA rules, I did indicate the formulas from here for secant, cosecant, and cotangent. We're going to be using them in the questions. We're going to be evaluating the problems by using these formulas as well. So as we navigate through these, I'm going to be indicating you more things from your unit circle. Last time, we also used the unit circle to indicate the reference angles. Okay, so taking you back here, and then I'm going to remove this one so I can indicate the next one. So we were using unit circle last time also. This is half of the unit circle. So 1/2 is right here. And this is 1 as the radius, 1 on that side. And then they are showing the calculations of this point, -√3/2 and 1/2. The point is on the unit circle, finding trig functions from a point on the unit circle. So for this point, we're going to find sine t, cosine t, tangent t, secant t, cosecant t, and cotangent t. How we can do that is if we know what angle is this one, okay? And if you remember, last time I made a trig table with you for sine and cosine values. Also, I indicated that every value on the unit circle, the first one is the cosine value, the second one is the sine value. So if this is the sine 1/2, that means if I recollect to you the unit circle, it would go, the trig table, it was like this. We made that unit circle, that trig table, writing the values of sine, cosine, tangent at 0, 30, 45, 60, and 90 degrees. So I'm going to do that again with you to remind you several things from here. So right here, I'm drawing another line. Right here, I'm trying to add one more line. It will be a little tight space, but let's see. And then here is a vertical line. Here's another one. Zero, 30, 45, 60, and 90. I'm going to write here. And then we go further down here. So here is sine function. Here is cosine function. COS cos. Here is tan function, the tangent. And then I teach you last time the values of sine and cosine at 0 and at 30 and at 45 and at 60 and at 90. And I told you a technique to write all of them without memorizing. So you can just do, okay, if you start writing 0 here, 1, 2, 3, and then 4. You divide them all by 4 and square root them. So I'm going to divide them by 4 first. 0/4, 1/4, 2/4, 3/4, 4/4. Okay. And then as we go from there, we're going to take a square root of all of them. So square root here, square root here, square root here, square root here, square root here. Now, if you think about calculating them, 0/4 is a 0. 1/4 square root is 1/2. 1/2. Square root 2/4 is square root 2/2 because square root 2 is square root 2 and square root 4 is 2. So square root 2/2. And then square root 3 over 4 is square root 3 over 2. And 4 over 4 is a 1. So square root of 1 is 1. Now to fill the next line, we just go like this was 0, 1, 2, 3, 4. Now we go 4, 3, 2, 1, 0, and we repeat the whole process. So we're gonna go, okay, this is 4, 3, 2, 1, and then 0. Then we divide each number by 4 and take a square root again. Divide by 4, divide by 4, divide by 4, divide by 4, and then divide by 4. And then you take a square root on all of them again. When we take square root here, it's 4 over 4, which is 1. Square root of 1 is 1. When we take a square root here, this is square root 3 over 2. Square root of 3 over 2. When we take a square root here, it's square root 2 over 2. When we take a square root here, it's 1/2. Square root of 1 is 1, square root of 4 is 2. 0 over 4 square root is 0. So now if you look carefully, this value 1 came here, this value square root 3 over 2 came here, the same stayed here, then 1/2 and then 0. And tangent is sine over cos. So sine value 0 over 1, this is gonna be 0. 1/2 divided by square root 3 over 2 is going to be 1 over square root of 3. 1 over square root of 3. And these two are same. So square root 2 over 2 divided by square root 2 over 2 is 1. Division of these two will give you square root of 3. And this last one, 1 over 0, is undefined. So I'm writing just undefined. Okay. Now, why I bring that back to your memory is I'm looking at this point that's given, and we are supposed to calculate these trig ratios from there. Okay. Now, when I look at this value, sine 1/2. Sine value 1/2 is at 30 degrees. 30 degrees means pi over 6 also in the radians. So this is same as the line that would be here in your unit circle. That's what this is telling you. So at 30 degrees. So this is sine 30 and cos 30. Cos 30 is square root 3 over 2. It's negative because it's in the second quadrant. So the angle they're telling us is 30 degrees from here. So that means that angle is your 180. Take away 30, which is 150 degrees angle. That's the measurement of this angle. They say the point this is on the unit circle, find sine t, cosine t, tangent, secant, cosecant, and cotangent t. We already have sine t from here. So we're gonna say, okay, the sine t is sine t is equal to 1/2. It's equal to 1/2. Then cosine t is equal to negative square root 3 over 2. square root 3 over 2. Now, if we know the sine and cosine, we can tell the tangent. It's right here in this one. And the tangent value is 1 over square root 3, but it's going to be negative as the cosine is negative because this point is in the second quadrant. So we will say tangent t is equal to sine over cosine, you can say, and you can write -1 divided by square root of 3. And then, as I mentioned earlier, the cosecant is opposite of whatever your sine is, always, always. Cosecant is gonna be opposite of whatever your sine is. So if sine is 1/2, cosecant will be 2 over 1. Cosecant will be 2 over 1. Cosine. Secant is opposite of the cos. So secant is going to be the flip over of the cos. So secant will be negative is going to stay negative, and then 2 over square root 3. 2 over square root 3. And then your cotangent is opposite of the tangent. So we can say cotangent t, cot t is equal to negative of square root 3 over 1. Or just write square root 3, just the reverse of that one. That's how you figure out these values. Let me know if a question, thought, or wonder came to your mind. Okay, about to erase this and take us forward. As we scroll down, the solution is also present right here in your book, so you may reread it and rethink and re-energize yourself with the information on this question. Now, similar questions will be there, but this table, the one that I was making, that is all together made here as well, 0, 30, 45, 60, and 90. I wanted to put it in the order in your mind. So sine, cosine, tangent, and then from sine, the opposite is cosecant. From cosine, the opposite is secant, and then from tangent, the opposite is cotangent. In the same way, like we were doing for sine, 0, 1, 2, 3, and 4, divide by 4, take a square root. That's how these numbers are appearing there. Then for cos, opposite of that, 4, 3, 2, 1, 0, divide by 4, take a square root. Those numbers appear there. Tangent is division of sine over cos. 0 over 1 is a 0. Square root 3 over 2 divided by 1/2 is giving you the value right here. Square root 3 over 1/2 divided by square root 3 over 2 will give you 1 over square root 3. And from there, to make it down to the value that they're writing, they have done rationalization here. Rationalization means they have multiplied with square root 3 on the top, square root 3 at the bottom. So square root 3 by square root 9 will give you this value. Then this is same number division is 1. This number divided by that number is square root 3. 1 over 0 is undefined. And then the secant opposite of the cos values. So 1 over 1 is going to be still 1 over 1. 3 square root 3 over 2 will become 2 over square root 3. And to get to this value, they have again rationalized here. If you flip over this, it will be 2 over square root 3. And then you rationalize. Rationalize means you multiply with square root 3 on the top and at the bottom. That will make it 2 square root 3 by square root 9, which is 3. And then opposite reverse of this is 2 over square root 2. And then 2 over square root 2 is also rationalized. So 2 over square root 2, you multiply with square root 2 on the top and at the bottom. it will become square root 2 over square root 4, which is 2. So 2 and 2 will cancel, leave you with square root 2. Flip over of this one is 2 over 1. Flip over of this is 1 over 0, which is undefined again. Cosecant is opposite of the sign. 1 over 0 is undefined. 1/2 will turn into 2 over 1. This will turn into 2 over square root 2, which is again rationalized to make square root 2. Square root 3 over 2 will become 2 over square root 3, and then you rationalize. And then you have 1 over 1, which stays as 1. Cotangent is flip over of the tangent. So this is 1 over 0, undefined. A flip over of this will be 3 over square root 3. You rationalize to get this number, 1 over 1. And then flip over of this is 1 over square root 3. You rationalize to get this number also, square root 3 over 3, and then the 0. So this is the whole table, which is known as the trig table that you can use for the sine, cosine, and tangent value. Then we will also be using reference angles to evaluate tangent, secant, cosecant, and cotangent of particular values. And we did talk about this last time also, that there are 4 quadrants: the first, the second, the third, and the fourth. All positive in the first one. So you can write an analogy, which I am going to say here. I use this analogy to tell my students that it's easy way to memorize. Add sugar to coffee. So what does add means here? Add means all positive. Sugar means sign positive and its opposite. Cosecant is positive. Rest all are negative. Rest all the functions will be negative here. Add sugar to coffee. 2 stands for tan. Tangent will be positive. Its opposite cotangent will be positive. Rest all will be negative. Coffee, C, stands for cos. Cos and its opposite secant will be positive. Rest all will be negative in this quadrant. What does it mean by positive and negative? As you look at the quadrants, this side x is positive, y is positive. This side x is negative, y is positive. This here x is negative, y is also negative. Down here x is positive, y is negative. Based off of that, these values are marked positive or negative. An analogy to memorize is add sugar to coffee, A for all, S for sine and cosecant, T for tangent and cotangent, C for cos and secant there. Okay. So with that said, if any question came to your mind, let me know. Taking us forward from that. Okay, now how to do when given an angle not in the first quadrant and use the reference angle to find all 6 trigonometric. I will show you that type of question, that how to do it. I'm going to take us down towards the questions now, so you get to see the problems based off of this. As we go in the section 5.3, the other trig functions, you will see this. Sine 0.45, cos 0.45, and tangent 0.45. So these few are based off of the calculator. I'm going to be sharing the calculator screen on the top to calculate with you and let you know that what is the value. So I'm going to share my calculator screen up on the top. Okay, I hope my calculator screen is now visible to you. This is the TI-84 calculator. You can use the regular or the TI-84. I think Desmos also has all the functions available to you. So we're supposed to calculate sine of 0.45. So you simply type sine of 0.45 and you will get a value. And the value that I'm getting is 0.43496. So I'm going to check 0.43496. Same way you will calculate cosine and the tangent value for that one using the calculator. Let me know if any question is this far. So we go further in question number 2, which is saying tangent is given 12 over 5 and they are in first quadrant. 0 to 90 degree means the first quadrant. Sine theta equal to what? So cos theta equal to what? And secant theta equal to what? So if you remember me in the beginning drawing a triangle, which was looking like this from the first quadrant. So if it's in the first quadrant, right here is gonna be your 1, right here is gonna be your x, right here is gonna be your y. This angle T, which was mentioned earlier, is now named as theta. So if you remember SOHCAHTOA analogy, T tangent TOA, tangent theta equals to opposite over adjacent TOA. So from this theta, opposite is this side, which is 12. Adjacent is this side, which is 5. So we have those two numbers as the information. And then we can find sine, cosine, and the secant. Sine is your opposite over hypotenuse. So opposite over opposite over hypotenuse would give you a number shared from there. So in this one, they didn't mention one thing, which I am thinking of. They did not mention it's a unit circle. So we cannot assume this side as your known side. We don't know what this one would be. This one was 1 in the given example that I shared with you if it's a unit circle. This one is simply saying that tangent is in the first quadrant and it's 12 over the 5. And we have to figure out opposite and adjacent are known, and we have to figure out this hypotenuse from there. So if you remember the Pythagorean, we can apply that to figure out this one. And if you apply Pythagorean and calculate quickly, let me know what you find for the hypotenuse side. C square is equal to A square plus B square. And I think 12 square is 144 and 5 square is 25. So if we add them up, it's 169, and 169 under the square root would give you 100. When you take a square root of 169, it would be 13. So this side would be 13, the hypotenuse side. So 13 on that one. And SOHCAHTOA rules say sine is opposite over hypotenuse. Opposite is 12, hypotenuse is 13. So the sine will be 12 over 13. Cosine is adjacent over hypotenuse. So adjacent is 5 and hypotenuse is 13. Secant is supposed to be opposite of the cosecant. So that will be 13 over 5. Just flip over off. The cos is secant. So 13 over 5. That finishes this one. Let me know if a question, thought, wonder come to your mind while looking at this calculation, what went where, and how did we do it. Couple seconds for you. Okay, about to erase this and taking us forward. Now we are given theta as negative 5 pi over 6. So firstly, you got to think, where is 5 pi over 6? Which quadrant? And then you're going to find all the values of secant, cosecant, tangent, and cotangent. If you remember, we have done the conversions between radians and degrees also. This is given in the radians. 5 pi over 6. Pi means 180. 180 and then divided by 6. 180 divided by 6 is 30 degrees. And 30 times negative 5 is negative 150. So negative angle. We got to find the location of this one. I am going to draw this angle. So here is the x-axis and here is the y-axis. And if we begin from here and we go down here, it's 90. We go here is 180 and 30 above that will be 150 negative. So here somewhere. So I am going to mark that this angle right here is negative 150. If that is negative 150, that means this angle from here is 30 degrees down this way. And it would be same as 30 degrees in the first quadrant. If you remember, this is a unit circle and 30 degrees from here would be somewhere here. Okay. And we know the values of your 30 degrees here. That's going to be the reference for cos 30 and sin 30. We know those values from the unit circle or from the trig table. Both can help you. So if you remember, like I remember my sine values and cosine values. So 0, 1/2, then 1 over, then square root 2 over 2, square root 3 over 2, and then 1. And I'm looking at 30 degrees. So my cos value at 30 degrees is square root 3 over 2. Divide, and the sine value is 1/2. This is in the third quadrant. Add sugar to coffee. Tangent is only positive. Tangent and cotangent are only positive. Rest all are negative. So both the sine and cosine will be negative here. So this would be -3 over negative square root 3 over 2. And then -1/2. That will be my cosine and the sine value. But I'm supposed to find the secant. Secant is opposite of the cos, so that will be -2 over square root 3. -2 over square root 3 is rationalized here by multiplying with square root 3. Cosecant is opposite of the sine, so -2 will be that one. Then tangent is sine over the cos. If -1/2 divided by this, that's gonna be 1 over square root 3. Rationalize it, and rationalization will give you square root 3 over 3. And then cotangent is opposite of the tangent. So 3 over square root 3, then rationalize it, which is going to be square root 3. You can read these values from the trig table also, which I showed you in the book, in case you forget how I calculated, how all the calculation went. You can go to this table, which was right here, and we were looking for 30 degrees. So 30 degrees cosine, square root 3 over 2, sine 1/2. And then you were looking for secant, which is this value. You were looking for cosecant, which is that value. Then cotangent, that value. You can go that route also by looking at the table. But if you do know the things, then you can calculate each time by yourself. Any question comes up, feel free to ask. And we move forward from here to the next one, which is question 4. So this is pi over 4. Pi over 4 means 45 degrees. So secant, cosecant, tangent, and cotangent we're going to find. You can either draw or you can look it up directly. Secant. Secant is right here on the table. Pi over 4, 45 degrees. And that is square root of 2. That's what will go into your first answer right here. And then cosecant is right here, 45 degrees, square root 2. So you go back and write that cosecant is square root 2. Then tangent 45 degrees. So tangent is right here, 45 degrees, it's 1, and you go fill that in there. Cotangent is opposite of the tangent, that's also going to be 1 over 1, and that's 1. Okay, that's that. Now taking us forward to the next one. Next one is saying sine theta is 2 over 5, and theta is in the quadrant 2. Then find cos, tan, secant, cosecant, and cotangent. So we got to draw here for this one also. We go here. We draw the x-axis. We draw the y-axis. And second quadrant is this one. So there is some angle theta. I am going to draw that one. So right here is angle theta. And then I go from here this way. Okay. Theta is in quadrant 2. So this is my triangle for that one. And if that's the triangle, here is the angle. This will be the x side, this will be the y side. Here will be the cosine and the sine value. Sine value is given 2 over 5. Sine is, from SOHCAHTOA rule, is opposite over adjacent. From this angle theta, opposite side will be this one, and adjacent will be this one. So we can find the hypotenuse by using Pythagorean. So c square is equal to a square plus b square. 2 square is 4. 5 square is 25. So that hypotenuse side is square root 29, this one. Now we can find cosine from here. Cosine is adjacent over hypotenuse. So that got to be 5 over square root of 29. They are showing it different than that. They have 21 square root. Did we miss something? Sine is 2 and 5. Theta is in the second quadrant, or maybe they're marking this one as this way, that starting from here, this is theta. And if that's theta, then this would be 180 minus theta. 180 minus theta. So we got to estimate that if they're marking that way, because 29 is not visible there. They're showing 21 for that one. So I'm going to refer back to one more thing to double check on this one. That so theta is in second quadrant. They're saying second quadrant, so second quadrant would be the same location that we have. How come they have 21? Sine. So I'm gonna try to go that this is cos of so there is a value sine 2 over 5. Sine theta is 2/5 and theta is in the second quadrant. Is in the second quadrant. What would be this angle? So 21, 2 squared is 4, 5 squared is 25, plus 4 is 29. Let's check if they do the same thing for the tangent. Yep, they are going with 21. I don't know where the 21 is kicking in from. We'll come back to this question in a couple seconds. So something is not clicking in my head right now for number 5. And we roll on to C to the section 5.4, and then we'll come back to this one, number 5. So 5.4 is right triangle trigonometry. And in this section, we have little more detail on this whole thing that we did in section 5.4. So the first thing that you're already familiar with is your Pythagorean for right triangle. And the second thing, as you see right here, is a point on the unit circle. This is x, y. So the cos is adjacent over hypotenuse, x over 1. They're showing the cos value. Likewise, the sine is adjacent. The sine is opposite over hypotenuse, so y over 1. Then they're showing that. Then they're showing all the 3 trig ratios for that. And then evaluating the trigonometric functions at the right triangle, 90-degree triangle. That's what we're going to do. The basic thing that we saw in the last section are similar in this section as well. So I'm going to show you some questions based off of that. We have basically word problems in this one. This is saying a radio tower is located 250 feet from a building. From a window in the building, the person determines that the angle of elevation to the top of the tower is 40 degrees and the angle of depression to the bottom of the tower is 27 degrees. How tall is the tower? So firstly, I'm going to try to draw the picture right here. And it says radio tower is located 250 feet from a building. So suppose the building is here. Radio tower is 250 feet. From the window in the building, a person determines that the angle of elevation to the top of the tower. So here is the tower. Is 40 degrees, and the angle of depression to the bottom of the tower is 27 degrees. So we have this one. And then we have this one. This angle is 40 degrees right here. And this angle right here is 27 degrees. So we are basically dealing two triangles in this one, and two angles are given, and one side is known in that. So that known side is 250. And we have to figure out how tall is the tower. So this height we're going to find. This is where the question mark is. And to figure out this height, we're going to be using the triangles that we see in the picture. And we're going to be using the trig ratios. And I'm going to show you a similar example to that and then bring back to this question, because there are multiple things that we're going to do in this problem. Okay, so bear with me for this is parallel example to what is given in our question. Our question has 250. This has 425. Radio tower is located 425 feet from the building. From a window in the building, a person determines that the angle of elevation to the top of the tower is 38 degrees. And the angle of depression to the bottom of the tower is 30 degrees. How tall is the tower? So we are finding the height of the tower here again. So in this one, the first thing they're marking is the building right here, the height of the building, and then they're marking the window in the building right here. So from the window, they are looking, and the elevation to the top of the tower is 38 degrees, and the depression to the bottom of the tower is 30 degrees this way. So they have selected to use tangent for this one. This distance is 425. So tangent is opposite over hypotenuse in the trig ratios. So we have 425. This side is marked by 1. This side is marked by 2. So tangent of 30 degrees is equal to y1 over 425, and tangent of 38 degrees is equal to y2 over 425. That will give you y1 and y2, and that will give you the height of this one as in total. And then I take us further a bit. The height h is equal to y1, which is this plus that. And calculations on the calculator will give you the approximate value of the height as 577.42 feet. exactly similar is our question. Our question is also having that scenario in this one. So when that is applied in our problem, we will reach to this one, 337.1562 in calculation. Only numbers we are changing is 250, 40 degrees, and 27 degrees. You can run that calculation and relook that problem. Question 2 is saying we are given a right angle triangle. Triangle may not be drawn to scale. Suppose C is 5. This side is 5 given to us. And A is equal to 15 degrees. This angle A is 15 degrees. We're going to be finding the small a, small b, and capital B angle. So firstly, we can find the angle B quickly because sum of the angles of a triangle is equal to 180 degrees. We know this symbol means 90 degrees. So this triangle is having 90 given, 15 given, and rest we are finding. So rest will be 180, take away the sum of these two, which is going to be 75 degrees. So angle B will be 75 degrees right here. And then if angle B is figured out, we're going to find A, side A, and then we're going to find side B. So to find side A, there are various methods to use. I don't know if you're familiar with the formula, which is called the sine rule and the cosine rule to find the missing side. Are you guys familiar with the sine rule and cosine rule for finding the missing side and missing angles? Let me know in the chat if you are. We can use that directly here. Okay. So that formula is A over sine A is equal to, when the right angle triangle is given like this, that formula works like this, A over sine A is equal to B over sine B. This is called law of sines, B over sine B is equal to C over sine C. Now, by looking at the question, we know the C. We know the angle C also because that's 90 degrees. We know this, we know the angle A, and we want to find the side A. So we will use these two, A over sine A equal to C over sine C. A over sine A equal to C over sine C. Now the A value is unknown. The sine A, angle A is 15 degrees. So we're gonna have sine of 15 degrees here equal to C. C is known to us as 5 divided by sine C. Sine C is 90 degrees. Sine 90 is 1, if you remember from the table. So A would be equal to, we're going to say A is equal to 5 times sine 15 on the calculator. So if you go to the calculator now and calculate A times sine 15, because I cross multiplied here, 5 times sine 15, sine 90 is 1. And if we use the calculator, which I was using earlier, you can use Desmos or your own calculator. I'm going to use Desmos here. My calculator logged out. I think I erased whatever I was writing when I shared the calculator. Yep, that happened. So C was 5 sine 15. So 5 sine 15, I'm going to calculate 5 times sine 15. And I'm getting 1.2940. 1.2940 on calculation. Now, if I know the A, I know the C already was given. C was given 5. A is calculated 1.29. I can find B by using Pythagorean, or I can still use the law. The law was, now I will use B over, I would use B over, because now I want to find B, B over sine B, sine B equal to C over sine C. So B is unknown. Sine B we calculated, that was 75 degrees earlier. So we're gonna say sine 75. C is 5. Sine C is 90 degrees. So when I do that, I'm gonna write in the next step, B is equal to 5 sine 75 degrees. This is what we will calculate on the calculator. And when you calculate that, you will reach to this number on the calculator. Check that if you calculate that on the calculator. 5 times sine 75. Are you reaching to 4.8296? 4.8296. Let me know in the chat once you're done calculating. 4.8296. Check that if you get that on your calculator. Thank you, Jonathan, for confirming. Okay, with that, we roll on to our next problem. Thank you, Valerie, for confirming. I'm gonna erase this one now. And we go right here on the third one. It says 19 feet ladder leans against a building so that the angle between the ground and the ladder is 82 degrees. How high does the ladder reach on the building? So suppose we have the building here, and suppose here is a ladder leaning on it, and it would make a triangle this way. It says the ladder is 19 feet. This is known to us, 19. The angle between the ground and the ladder is 82. This angle is known. How high does the ladder reach on the building? This one we're gonna find. So, SOHCAHTOA rules can be applied here. If you remember, sine of theta is opposite over hypotenuse. So theta is given here, 82 degrees. So we'll say sine 82. Sine 82 equal to opposite, which is unknown. So let's mark that X over hypotenuse 19. So that X unknown will be 19 times sine 82. Go ahead, calculate that on the calculator and let me know if you end up calculating 18.81. 19 times sine 82 on the calculator. Okay, perfect. So we go further from there, erase this one. And we are again given a right angle triangle. Sides are marked for us. Triangle may not be drawn to scale, they're saying. Side A is given as 12. This one is 12. This one is 10. Find exact value or give at least 2 decimal places. So sine of angle A. So firstly, we will find C by using Pythagorean. C square is equal to 12 square plus 10 square. So we have 144 plus 100, which is 244. Then we find C. C is square root of 244. Calculate that on your calculator. Let me know what you find. Then we're going to find sine A. Sine A is opposite over hypotenuse. Opposite is 12. Hypotenuse is square root of 244. So calculate that. And let me know your answer up to 2 decimal places. Okay. We can also do this by using exact values, like they have shown the exact values, and see if you are getting this one as, when we simplify, we will get 12 over 61 times 4. Would that be 244? Check that on the calculator. So this 244, they have broken down to 4 and 61. That 4 square root is 2. 2 divided by 12 is 6. So that gives them 6 over square root 61. Then you multiply with square root of 61 on the top and square root of 61 at the bottom to rationalize. So that will be 6 square root 61 over 61. Then your cos A, cos is adjacent over hypotenuse. So adjacent here is 10, hypotenuse is square root 244. So square root 244 is again 4 square root, which is 2, square root of 61. So 10 divided by 2 is 5. So this will be 5 over square root 61. That will be cos, and they have rationalized the answer. So to rationalize, we multiply by square root of 61 and square root of 61 at the bottom. So 5 square root 61 over 61. Tangent is sine over cos. So if you divide these two, it will be 6 over 5. Then secant is opposite of the cos. So 61 over this, and then you again rationalize, or square root 61 over 5, that will be. Cosecant is opposite of the sine, so 61 square root over 6. Cotangent is opposite of the tan, so 5 over 6. That's how you figure this one out. We go forward from here to the next one, which is similar again, exact same thing in number 5. So I will skip number 5 for you to do by yourself. And about to erase this writing before reading the next one. This is saying a survey team is trying to estimate the height of a mountain above a level plane. From one point on the plane, the team observed that the angle of elevation to the top of the mountain is 26 degrees. From a point 1,500 feet closer to the mountain along the plane, the team find that the angle of elevation is 29 degrees. How tall is the mountain? Round to 2 decimal places. So in this one, again, 26 degrees is the angle, and then 29 degrees is the angle. So here are some steps that I'm going to share with you, which are attached right here. We will need to find the height of the mountain, which we consider as y, and x is the distance from the mountain to the 1,500 feet closer. We use the tangent of angle 26 degrees. So tangent of 26 degrees is equal to y, the height of the mountain, divided by the base, which is x plus 1,500. The next thing, the other angle, which was 29 degrees, that is tangent 29 degrees, y over the x. Now we have two equations with the tangent. If we solve each for x, then we can set the two expressions equal to each other and solve for y. So they took the first one, and then they cross multiply equal to y and simplify that for x, and then substitute that into the other one. This whole thing is there. Then simplify the second one for the x. This is the x value. This is also the x value. You set them up equal to each other. You cross multiply, and when you cross multiply, your equation has only one variable, which is y. And then you collect the y terms on one side, rest on the other, calculate tangent 26, 29 on the calculator, put that in, and you will get the height as 6,091.22 feet for the problem. So that was this one. And then we have another one similar to this one in question number 7. Says angle of elevation to the top of the building in New York is found to be 3 degrees from the ground at a distance of 2 miles from the base of the building. Using this information, find the height of the building round to the 10th. And hint they're giving that make sure you convert your mile into the feet. 1 mile is equal to 5,280 feet. So this is exactly similar to the last one. You will apply the tangent formula, and when you calculate, you will reach to an answer of 553. 553 in there, and I'm going to show you probably a similar example to this one. Here is a parallel example to that one. The angle of elevation, this is the height, and this was the distance in miles. So tangent is equal to height over the base. Whatever the angle is that we fill in here with the tangent, and then cross multiply to find the height, and then convert the miles into the feet by multiplying with 5,280. So exact same calculation we're gonna do in our problem. And when you do that same calculation here, you will get 553.4261 feet. Number 8 is also on the angles. Find x correct to 2 decimal places. Triangle is not to the scale. We are seeing 65 degrees on one side and 34 degrees on the other side, and we are seeing the height as 91 degrees. And we are supposed to find the x. So to figure out the x, if I am right here in this triangle, I will say, okay, so the tangent here, tangent we can use again here, tangent of 34 degrees, tangent of 34 is equal to, from this angle, opposite over the adjacent. So that will be 91 over this distance, whatever is this distance. We don't know because x is unknown here. So we're gonna say some variable y here. And then for tangent 65 degrees, tangent 65 degrees, it's 91 over. This gap will be now the total x minus the y. We solve both the equations for y. We set them equal to each other, and we will figure out the x value from there. So from the first one, we're going to have y equal to 91 over tangent 34. Tan 34. From the second one, we're going to have x minus y equal to 91 over tangent 65. Then from here, to find y, it's y is equal to x minus 91 over tangent 65. This is one equation in y, and we have the first equation in y. We set them both equal to each other and we solve for x. So we're gonna say, okay, this was y is equal to, so that means 91 over tangent 34. 91 over tangent 34 is equal to x minus 91 over tangent 65. Then you keep the x wherever it is. You move this one over here. You simplify this. You simplify this. Add them up and see if you're finding the x value as 177.3470. Check that out. 91 over tangent 31 plus 91 over 65. Let me know once you reach to the answer. Let me know if you get to 177.347 in your calculation. Thank you, Valerie, for confirming. And about to erase this one. If any question is there, let me know. So that was your section 5.4. And each and every question has a worked example or detailed solution available along with our discussion on this section. 5.3 and 5.4, I highly recommend you get done by the next meeting. And our quiz and the review is also open. So if you go ahead and try those, then I will reflect back on the review in our next meeting. And we will head towards the next chapter as well on Thursday, chapter 6. Okay, let me know if there's any question, thought, or wonder is on the top of your mind before we depart tonight. So 5.3 and 5.4 is your goal until we meet on Thursday.
I have a question.
Go ahead.
If we're not, usually I have class during this time. Is there another way that I could attend the Zoom meeting, like on a different time?
Time is this one, and this was selected by all the students all together when we started it, but there are recorded videos of each and every session.
Where are they on Canvas?
Huh?
Are they on Canvas?
Yes, they are on Canvas. Let me show you that. And Let's go to the canvas right here. All the recordings I put right here under Tech Connect Zoom. Let me share my screen. So like if you go right here, it says cloud recordings. So anytime you're not able to make it, you can see the recording.
Oh, okay.
There,
Thank you.
yeah, all the sessions are recorded here.
Oh, okay. Yeah, I
Mhm.
wasn't aware that we were supposed to vote for a Zoom meeting, like for a time.
Oh, okay.
Yeah, sorry about that.
Yeah, no worries. So anytime anything comes up, either join live with me to get that question or send me an email for your thing that you're looking forward to or you're wondering about.
Okay, thank you.
And Matthew, for your question, if you need any other help on trigonometry, let me know. I can record more or let you know more about it. You are welcome. You too have a great night.